The Commercial Aircraft Corporation of China, or COMAC, stands as a testament to China's ambition to become a major player in the global aviation industry. Founded with the vision to challenge the duopoly of Airbus and Boeing, COMAC aims to revolutionize the aviation landscape by introducing innovative and competitive aircraft. Established in 2008, COMAC is more than just an aircraft manufacturer. It symbolizes China's strategic intent to assert its technological prowess and economic strength on the world stage, reflecting the nation's broader goals of modernization and self-reliance. It represents China's strategic goal of reducing its reliance on foreign companies, particularly Airbus and Boeing, for large passenger aircraft. By developing its own aircraft, China seeks to secure its aviation future and mitigate risks associated with geopolitical tensions and trade dependencies. This ambition is deeply intertwined with China's broader economic and technological aspirations. The success of COMAC is seen as a critical component of China's plan to become a global leader in high-tech industries, driving innovation and economic growth. COMAC's flagship project, the C919, embodies this vision. The C919 is not just an aircraft. It is a symbol of China's determination to compete on equal footing with established aerospace giants and to showcase its engineering capabilities. The C919 is a narrow-body airliner designed to compete directly with the Airbus A320neo and Boeing 737 MAX. With advanced aerodynamics, fuel-efficient engines, and state-of-the-art avionics, the C919 aims to offer airlines a cost-effective and reliable alternative. It represents a significant step forward for China's aviation industry, showcasing the country's growing technological capabilities. The development of the C919 has involved extensive research and collaboration with international partners, highlighting China's commitment to achieving excellence in aviation. The success of the C919 is crucial for COMAC and for China's ambition to establish itself as a global leader in aircraft manufacturing. A successful C919 program would validate China's efforts and pave the way for future projects, including wide-body aircraft. However, COMAC's path to success is fraught with challenges. The complexity of aircraft manufacturing, coupled with the need for rigorous safety and certification standards, presents significant hurdles that COMAC must overcome. One of the most significant hurdles is the company's dependence on foreign suppliers for critical components, particularly aircraft engines. These engines are the heart of any aircraft, and securing a reliable and independent supply is essential for COMAC's long-term success. This reliance on foreign technology exposes COMAC to potential disruptions in the global supply chain, especially in light of ongoing geopolitical tensions. Trade restrictions and political conflicts could jeopardize the availability of essential components, impacting production timelines and costs. The intricate web of international partnerships and dependencies in the aviation industry makes COMAC's quest for self-sufficiency all the more complex. Building a robust domestic supply chain requires significant investment, time, and expertise. The development and production of modern aircraft necessitate expertise and resources that few countries possess. COMAC must navigate these challenges while ensuring that its aircraft meet international safety and performance standards. China recognizes that achieving true independence in aviation requires mastery over the entire supply chain, from raw materials to advanced technology. This includes developing domestic capabilities in areas such as materials, science, precision manufacturing, and avionics. COMAC's journey, therefore, is not just about building airplanes, but about fostering a robust and self-reliant aerospace ecosystem within China. This ecosystem encompasses research and development, manufacturing, supply chain management, and talent cultivation. The stakes are high, as success would not only have economic benefits, but also enhance China's global prestige and influence. A thriving aviation industry would position China as a formidable player in the global market, capable of shaping the future of air travel. At the heart of COMAC's challenge lies a critical component, the engine. The engine is not just a power source, but a complex system that determines the aircraft's overall performance, efficiency, and reliability. The C919 is powered by the CFM LEAP-1C, a state-of-the-art turbofan engine produced by CFM International, a joint venture between GE Aviation of the United States and Safran Aircraft Engines of France. This collaboration brings together decades of expertise and cutting-edge technology from both companies. While this engine choice provides the C919 with excellent performance and fuel efficiency, it also highlights COMAC's dependence on foreign technology. This reliance on external sources for such a vital component raises questions about the long-term sustainability of COMAC's production capabilities. The LEAP-1C engine is not merely a component but a highly sophisticated piece of engineering that is crucial for the C919's operational success. Its advanced materials and design innovations are the result of extensive research and development efforts. Its advanced design contributes significantly to the aircraft's fuel efficiency, range, and environmental performance. The engine's ability to reduce emissions and noise levels is particularly important in today's environmentally conscious market. Procuring these engines from CFM International represents a significant portion of the C919's overall production cost, impacting COMAC's profit margins. The high cost of these engines is a major factor in the overall financial equation of producing the C919. The reliance on foreign-made engines has substantial financial implications for COMAC. It affects not only the cost structure, but also the pricing strategy and competitiveness of the C919 in the global market. The purchase of these engines from CFM International represents a significant outflow of capital from China. This financial outflow can have broader economic implications, affecting the balance of trade and foreign exchange reserves. This dependence also exposes COMAC to potential price fluctuations and supply chain vulnerabilities, which could impact its production schedule and profitability. Any disruption in the supply chain could lead to delays and increased costs. Furthermore, relying on foreign suppliers for a critical component like the engine creates a strategic vulnerability for COMAC and, by extension, China. This reliance could be a significant risk factor in the company's strategic planning. This dependence could be exploited in times of geopolitical tension, as the supply of engines could be disrupted or halted entirely, jeopardizing COMAC's ability to produce and deliver aircraft. Such a scenario could have far-reaching consequences for China's aviation ambitions. This vulnerability underscores the need for China to achieve self-sufficiency in aircraft engine technology. Investing in domestic research and development is crucial for reducing dependence on foreign suppliers and ensuring the long-term success of China's aviation industry. The dependence on foreign, particularly American technology for the C919's engines, injects a significant geopolitical dimension into COMAC's ambitions. This reliance highlights the intricate web of global supply chains and the vulnerabilities that come with it. The relationship between the United States and China has become increasingly strained in recent years, marked by trade disputes, technological competition, and strategic rivalry. These tensions have led to a series of tariffs, sanctions, and other economic measures that have impacted various industries. This complex geopolitical backdrop casts a shadow over COMAC's reliance on the CFM LEAP-1C engine. The engine, a product of a joint venture between GE Aviation and Safran Aircraft Engines, is a critical component for the C919's performance and efficiency. The U.S. government possesses the authority to restrict or prohibit the export of sensitive technologies, including aircraft engines, for national security or foreign policy reasons. Such measures have been used in the past to curb the technological advancements of rival nations. In the context of escalating tensions with China, there is a growing concern that the U.S. might leverage its control over the supply of LEAP-1C engines to exert pressure on Beijing. This could be part of a broader strategy to limit China's rise in high-tech industries. The potential consequences of such a move would be significant. It could halt production lines, delay deliveries, and force COMAC to seek alternative, possibly less efficient, engine suppliers. For COMAC, losing access to the LEAP-1C engine would be a major setback, potentially grounding its C919 program and severely impacting its production plans. This would not only affect COMAC's market position, but also its reputation as a viable competitor in the aviation industry. It would also undermine China's efforts to break into the global commercial aviation market. The C919 is seen as a symbol of China's technological progress and ambitions to challenge Western aerospace giants like Boeing and Airbus. Moreover, the fallout from such an action would extend far beyond COMAC. It could lead to a re-evaluation of global supply chains and force other countries to reconsider their dependence on U.S. technology. It would send shockwaves through the global aviation industry, disrupting supply chains and creating uncertainty for airlines worldwide. airlines might face delays in aircraft deliveries and increased costs, affecting their operations and profitability. This scenario underscores the interconnectedness of the global economy and the potential for technology to become a pawn in international disputes. The aviation industry, being highly globalized, is particularly vulnerable to such geopolitical maneuvers. Recognizing the strategic vulnerability of relying on foreign engine suppliers, China has embarked on an ambitious endeavor to develop its own indigenous aircraft engine. This initiative is part of a broader strategy to achieve self-reliance in critical technologies and reduce dependency on Western aerospace giants. The Aero Engine Corporation of China, a state-owned enterprise, is leading the charge with the CJ1000A, a turbofan engine specifically designed for the C919. This engine is seen as a critical component in China's quest to compete with established aircraft manufacturers like Boeing and Airbus. Developing a modern, high-performance turbofan engine like the CJ1000A is a monumental undertaking. It involves not only the creation of new technologies but also the establishment of a comprehensive ecosystem for research, development, and production. It demands advanced engineering expertise in areas like materials, science, aerodynamics, combustion, and control systems. Each of these fields requires specialized knowledge and years of experience to master. These technologies are complex and require years of research, development, and rigorous testing. The process involves multiple iterations and continuous improvements to meet the stringent standards of the aviation industry. China faces numerous challenges in its quest to master this technology. These include not only technical hurdles, but also the need to build a skilled workforce and foster innovation within the industry. One of the most significant hurdles is the lack of experience in designing and manufacturing high-bypass turbofan engines with the performance and reliability required for commercial aviation. This inexperience can lead to delays and increased costs. Developing such an engine requires overcoming numerous technical complexities, including achieving high thrust-to-weight ratios, ensuring fuel efficiency, and meeting stringent noise and emission standards. Each of these factors is crucial for the engine's commercial viability. Another challenge is the availability of specialized materials capable of withstanding the extreme temperatures, pressures, and stresses present within a jet engine. These materials are essential for maintaining the engine's performance and longevity. These materials, often referred to as superalloys, are critical for the engine's durability and performance. They must be able to endure the harsh conditions inside the engine without degrading over time. China is still working to develop a robust domestic supply chain for these materials, which are often subject to export controls by Western countries. This adds another layer of complexity to the already challenging task of developing a world-class jet engine. Faced with the potential threat of U.S. engine export restrictions, COMAC might explore alternative suppliers. This could involve looking into partnerships with countries that have a history of aerospace development or investing in domestic research and development to mitigate dependency on foreign technology. However, viable options are limited. The complexity of aircraft engine technology and the stringent safety standards make it challenging to find suitable alternatives quickly. Russia, with its experience in aircraft engine manufacturing, might seem like a potential candidate. The country has a long history of aerospace innovation and has previously collaborated with China on various projects. However, Russian engines, while generally robust, do not yet match the fuel efficiency and environmental performance of their Western counterparts. This gap in performance could affect the competitiveness of COMAC's aircraft in the global market. Furthermore, the ongoing conflict in Ukraine and the subsequent sanctions on Russia make such a partnership highly unlikely in the current geopolitical climate. These sanctions have severely impacted Russia's ability to engage in international trade and technology exchange. European companies, while possessing advanced engine technology, are also subject to U.S. export control regulations, particularly for components with American origins. This regulatory environment complicates potential collaborations with COMAC. This limits their ability to freely supply engines to COMAC without U.S. approval, especially for sensitive technologies. Navigating these regulations requires careful legal and strategic planning. The global aircraft engine market is dominated by a handful of established players. These companies have built extensive networks and have significant influence over the industry's standards and practices. These companies have decades of experience and have invested heavily in research and development, giving them a significant technological edge. Their continuous innovation keeps them at the forefront of the industry. Breaking into this market and challenging the dominance of these established players is a daunting task that requires significant investment, technological prowess, and time. New entrants must overcome substantial barriers to entry. In essence, COMAC's options for securing alternative engine supplies are constrained by both technological and geopolitical factors. These constraints limit the company's ability to quickly adapt to changing circumstances. This situation highlights the company's vulnerability and the importance of China's pursuit of self-sufficiency in aircraft engine technology. Developing domestic capabilities is crucial for long-term stability and growth. It also underscores the strategic nature of the aviation industry and the potential for technology to become entangled in broader international power dynamics. The interplay between technology and geopolitics can significantly impact the future of global aviation. While aviation remains one of the safest modes of transportation, the possibility of another tragic accident always looms. Despite advancements in technology and rigorous safety protocols, the inherent risks cannot be entirely eliminated. The repercussions of such an event would be far-reaching, affecting multiple facets of the industry and beyond. Firstly, public trust in air travel would be severely shaken, leading to a potential decline in passenger numbers and a shift in travel preferences. The psychological impact on passengers cannot be underestimated. Fear and anxiety could deter people from flying, opting instead for alternative modes of transportation such as trains or cars, which could further strain other sectors. Fear and anxiety could lead to a significant decline in air travel, affecting airlines' revenue streams and destabilizing the broader travel industry. This downturn could result in job losses, reduced flight schedules, and even the bankruptcy of smaller carriers. Secondly, regulatory bodies around the world would likely implement swift and stringent changes. These could range from more rigorous safety inspections to mandatory upgrades in aircraft technology, potentially grounding fleets for extended periods. While these measures aim to enhance safety, they also come with substantial costs and operational disruptions for airlines and manufacturers. The need for new parts, retraining of staff, and compliance with updated regulations could strain resources. Financially, the impact on aviation companies could be catastrophic. Stock prices of affected airlines and manufacturers would likely plummet, leading to massive financial losses and a potential loss of investor confidence. Insurance premiums would skyrocket, further straining the already tight profit margins in the aviation sector. This increase in costs could be passed on to consumers, making air travel more expensive and less accessible. Finally, the international ramifications cannot be ignored. Aviation incidents often lead to diplomatic tensions, especially if the crash involves aircraft or components from different countries, complicating international cooperation. Investigations can become politically charged, complicating international relations, and potentially leading to trade restrictions or sanctions. These diplomatic strains could hinder global aviation agreements and collaborative safety initiatives. In summary, the consequences of another tragic aviation accident would resonate far beyond the immediate loss of life. The ripple effects would touch public sentiment, regulatory landscapes, financial stability, and international diplomacy, underscoring the critical importance of maintaining and improving aviation safety standards. The aviation industry must remain vigilant and proactive to prevent such tragedies and mitigate their extensive impacts. Ryanair, one of Europe's leading budget airlines, is now facing a new challenge. The airline, known for its cost-effective operations and extensive network, is grappling with external pressures that could reshape its future. Potential tariffs, resulting from the policies enacted by the Trump administration, have forced the airline to reconsider its current aircraft orders. These tariffs, aimed at protecting domestic industries, have inadvertently increased the cost of importing aircraft, putting a strain on Ryanair's budget. The increased costs associated with these tariffs have made it necessary for Ryanair to explore alternatives. Among these alternatives, Ryanair is seriously considering planes from COMAC, China's burgeoning aircraft manufacturer. COMAC's competitive pricing and growing reputation in the aviation industry make it an attractive option for the budget airline. This potential shift in their fleet could mark a significant change in the aviation industry, highlighting the growing influence of Chinese aviation manufacturers on the global stage. If Ryanair proceeds with this change, it would not only be a strategic economic decision, but also a symbolic one, signaling a departure from traditional Western aircraft suppliers. It would signal a shift in the balance of power within the aviation sector, as more airlines might look towards China for cost-effective solutions. This move could encourage other airlines to explore similar options, thereby potentially accelerating the acceptance and integration of Chinese aircraft in the global market. Gap 1S. However, this decision is not without its risks. The aviation industry is highly competitive, and any misstep could have significant repercussions. Ryanair would need to consider the reliability, safety, and performance of COMAC planes, as well as the potential political and economic ramifications of such a significant shift. The airline must weigh the benefits of lower costs against the risks of adopting relatively new technology. Ultimately, Ryanair's exploration of COMAC planes underscores the complexities and interconnectedness of the global aviation industry, where economic policies, technological advancements, and geopolitical factors all play a crucial role in shaping the future of air travel. This decision could set a precedent for other airlines, influencing the direction of the industry for years to come. As Ryanair and other airlines contemplate the possibility of integrating COMAC's aircraft into their fleets, a crucial question looms large. How long will it take for COMAC to develop their own Chinese engines? This question is not just about time, but also about the technological and economic hurdles that need to be overcome. The answer is complex and multifaceted. It involves not only the engineering challenges, but also the need for extensive research and development, as well as the establishment of a robust supply chain. Developing a reliable and competitive engine is no small feat. It requires years of innovation, testing, and refinement to meet the high standards set by the global aviation industry. Industry experts estimate that it could take COMAC at least a decade to produce engines that can match the performance and reliability of those from established Western manufacturers. This timeline is based on the current pace of technological advancements and the learning curve associated with engine development. This timeline is influenced by several factors, including technological advancements, regulatory approvals, and the ability to produce engines at scale. Each of these factors presents its own set of challenges that COMAC must navigate. Reliability is another critical aspect. An engine's reliability is paramount for the safety and efficiency of an aircraft, and achieving this requires rigorous testing and quality control. COMAC's engines will need to undergo rigorous testing and certification processes to ensure they meet international safety standards. This includes stress tests, performance evaluations, and compliance with global aviation regulations. Any failure in this regard could have severe consequences, not just for COMAC, but also for any airline that chooses to adopt their technology. The reputational risk and potential financial losses could be significant. Cost is also a significant consideration. The financial investment required for developing advanced aviation engines is substantial and involves long-term commitment. Developing sophisticated aviation engines requires substantial investment in research and development, manufacturing infrastructure, and skilled labor. These investments are crucial for ensuring the quality and competitiveness of the engines. While China has the financial resources to support such endeavors, the initial costs could be high, potentially offsetting the savings airlines hope to achieve by switching to Chinese-made planes. The return on investment may take years to materialize. Moreover, geopolitical factors cannot be ignored. The global political landscape can significantly impact the aviation industry, influencing trade policies and market access. The global aviation industry is heavily influenced by international trade policies, diplomatic relations, and economic sanctions. These factors can either facilitate or hinder COMAC's entry into international markets. Any shifts in these areas could impact COMAC's ability to compete on the world stage. Political tensions and trade restrictions could pose significant barriers to market entry and growth. In conclusion, while the prospect of COMAC developing their own engines is promising, it is fraught with challenges. The path to success is long and requires overcoming numerous technical, financial, and geopolitical obstacles. Airlines like Ryanair must weigh these factors carefully as they consider their future fleet compositions. The decision to adopt COMAC's technology involves assessing both the potential benefits and the associated risks. The journey ahead for COMAC is paved with both opportunities and obstacles, and only time will tell how they navigate this complex landscape. The outcome will depend on their ability to innovate, adapt, and collaborate on a global scale. If the USA stops supplying engines to COMAC, where can COMAC turn? This question is not just about finding new suppliers, but also about ensuring the quality, reliability, and efficiency of the engines that will power China's aviation future. This is a critical question that could shape the future of China's aviation ambitions. The ability to secure a stable and high-quality engine supply is fundamental to COMAC's success in the global market. With the United States' significant influence over global aviation technology, finding alternative suppliers is no small task. The U.S. has long been a leader in aviation innovation, making its engines highly sought after worldwide. One potential ally is Russia. Russia's aviation industry, while not as advanced as the U.S., has a history of producing reliable engines and has been looking to expand its market reach. Russia has its own engine manufacturing capabilities and has shown willingness to collaborate with China on various high-tech projects. This partnership could be mutually beneficial, providing Russia with a significant market and China with a crucial supply of engines. However, Russian engines may not meet the same standards of efficiency and reliability as their Western counterparts. This discrepancy could affect the performance and competitiveness of COMAC's aircraft. Additionally, geopolitical tensions involving Russia could complicate matters further. Sanctions and international relations could impact the stability and reliability of this potential supply chain. Another option could be European manufacturers, such as Rolls-Royce or Safran. These companies are known for their advanced technology and high-quality engines. However, these companies are also subject to Western trade controls and may face pressure from the USA to limit their dealings with COMAC. This could restrict COMAC's access to these high-quality engines. This scenario underscores the complexity of navigating international trade laws and diplomatic relations. COMAC would need to carefully manage these relationships to secure a stable engine supply. Then there's the possibility of developing indigenous Chinese engines, which would give China full control over its aviation technology and reduce dependency on foreign suppliers. But as we've discussed, this is a monumental task that could take years, if not decades, to achieve. The development of a competitive engine requires significant investment in research, development, and testing. Even if China accelerates its research and development, the immediate gap left by the absence of American engines would be challenging to fill. This could impact COMAC's production timelines and market competitiveness. The question of engine parts is also crucial. Many components used in aviation engines are sourced globally, involving intricate supply chains that span multiple countries. If the USA imposes trade restrictions, it could severely impact the availability of these vital parts, further complicating COMAC's efforts to produce their own engines. This could lead to delays and increased costs. If the USA imposes trade restrictions, it could severely impact the availability of these vital parts, further complicating COMAC's efforts to produce their own engines. This could lead to delays and increased costs. In summary, if the USA halts its supply of engines to COMAC, the road ahead becomes even more arduous. The challenges are multifaceted, involving technology, geopolitics, and complex supply chains. While Russia and Europe present potential alternatives, they come with their own sets of challenges and limitations. Each option has its own risks and uncertainties. Developing indigenous engines is a long-term goal that won't solve immediate needs. This requires a strategic vision and sustained effort over many years. The interconnected nature of global supply chains adds another layer of complexity, making it clear that COMAC's path to engine independence is fraught with hurdles. The global nature of the aviation industry means that no country can easily go it alone. The future of COMAC's engine supply chain will depend on how effectively China can navigate these geopolitical and technological challenges. Success will require innovation, diplomacy, and strategic partnerships. Only time will reveal whether COMAC can secure the engines it needs to continue its ascent in the global aviation industry. The stakes are high, and the world is watching to see how China will rise to this challenge.